right now, like as we're actually sitting here talking, Microsoft's identity systems are actively blocking something in the neighborhood of 7,000 password attacks.
Yeah, it's
And
staggering.
that's not per day or, per hour. That is per second.
Per second, yeah. And while those brute force attacks are just hammering the front door, somewhere deep in the architecture, there's an ensemble of over 100 autonomous AI agents basically arguing with itself.
Right.
Like they're systematically debating, writing, and executing code to hunt down these deep kernel-level vulnerabilities, specifically in the TCP/IP stack, before human engineers even, realize a flaw exists.
Which honestly perfectly frames the reality of the modern tech stack that we're dealing with. So welcome back to the Deep Dive, everyone. Our mission today is to extract the most critical insights from the latest edition of Andrew Kagan's weekly technical newsletter.
Always a dense read.
Oh, incredibly dense. We're looking at 8 distinct focus areas of enterprise technology today, from Azure and Microsoft 365 all the way down to security and industry news. Because if you're listening to this, you need to stay sharp without just drowning in information overload.
Exactly.
But reading through these updates, a really stark reality emerges. The era of generative AI, where you prompt a chatbot and it sort of passive-aggressively summarizes a PDF for you, that era is over.
It's done. Yeah, we've completely entered the era of agentic AI.
Right.
It's that massive shift from generation to autonomous execution. I mean, we're no longer building systems that just talk to us. We're deploying systems that hold the actual authority to take action. They modify infrastructure. They secure networks on our behalf.
And to really understand how sweeping this is, I think we have to start at the physical edges of the network. Because if an AI agent is going to autonomously manage a physical environment, it can't be tethered to some massive centralized server farm in Virginia.
No, it needs ubiquitous connectivity.
Exactly. So I was looking at the industry news section, and Amazon Leo is aggressively aiming to double the pace of its satellite broadband network rollout. And, my initial thought was just, okay, better Wi-Fi for remote cabins.
Right, the consumer angle.
Yeah, but the enterprise application here is what completely changes the game for AI.
Because it enables hyperscale edge inference.
Yeah.
Like when you achieve high-speed, low-latency connectivity anywhere on the physical globe, you stop sending data back to the cloud to be processed.
You just process it right there.
Right there on the device.
Mm-hmm.
We are literally talking about deploying autonomous AI agents directly onto wind turbines in the middle of the ocean, or integrating them into industrial bakery ovens in rural manufacturing plants so they can monitor and adjust the role dynamics in real time.
Wait, okay, but the logistics of that seem like an absolute nightmare.
Oh, historically, yes.
Because if your compute power is distributed across thousands of wind turbines and bakery ovens globally, how do you manage that infrastructure? I mean, looking at the Azure updates, Microsoft is pushing tools to govern thousands of Kubernetes clusters without manual intervention. But, and correct me if I'm wrong, relying on automated syncing at that scale, especially with something like GitOps, doesn't that usually result in a massive problem with configuration drift?
It does, yeah. The technical hurdle there is actually known as GitOps reconciliation lag.
Okay, right, because if I understand GitOps correctly, you basically have a central repository, like a blueprint of how every single cluster should be configured.
Exactly.
And the system relies on individual agents on those edge devices to constantly check in, compare their local state to the central blueprint, and update themselves.
Right, they pull the updates.
But when you scale that to thousands of edge devices over satellite links, isn't the central system essentially too slow to process its own backlog of state checks?
Precisely. The system just gets totally bogged down verifying states. So by the time the central blueprint realizes that a specific wind turbine in, say, the North Sea is running a vulnerable, misconfigured container,
It's already too late.
yeah, an attacker might have already exploited it, or the machinery might have failed. So to solve this, Microsoft is moving away from purely reactive syncing. The new fleet management tools built into Azure, they orchestrate updates proactively.
Okay, meaning what exactly?
The control plane pushes the governance policy outward simultaneously. So it guarantees consistency without waiting for thousands of devices to independently ask, hey, am I out of date?
Wow, which completely takes the burden off the infrastructure engineers.
Absolutely.
And for developers who just want to bypass cluster management entirely, I noticed Azure just rolled out Azure Container Apps Express ACA. It looks like essentially an architectural easy button.
It really is.
Like you hand Azure a containerized app and it just handles the underlying compute, the scaling, the production defaults without you having to provision any of the infrastructure.
It abstracts away all that foundational complexity because, frankly, the organizations building the most advanced technology right now, they don't want to spend their engineering hours configuring nodes.
No, they want to build features.
Right. They need to spend that time building the logic and intelligence of their applications.
Which brings up a massive bottleneck, actually, because an application running globally on a beautifully managed Azure cluster is kind of useless if the AI agent driving it doesn't actually understand the business it works for.
That's the core issue right now.
Yeah. I mean, in the data analytics and AI space, we see models getting incredibly sophisticated. Microsoft Foundry just released Grok 4.3, and Foundry Local 1.1 is bringing live transcription and local embeddings straight to developer machines.
And that local embeddings feature is actually quite profound.
Oh, really? How so?
Well, rather than sending proprietary text to the cloud, developers can locally translate their documents into mathematical vectors embeddings. So it allows the AI to calculate the conceptual distance between ideas securely on their own hardware.
Okay, that's huge for privacy. And they also release capabilities that let users generate complex SQL database queries directly from plain English.
Yes.
So anyone can just type, like, show me last quarter's sales numbers by region, and the AI writes the underlying code to pull the records. But the ability to write a SQL query doesn't mean the AI understands the context of the data.
Not at all.
And that's the wall every enterprise is hitting. Like, an agent can retrieve a customer record, sure, but it doesn't know the implicit rules of how your specific sales team is supposed to interact with your legal team based on that record.
Exactly. That is the context bottleneck. It's the difference between having access to information and having actual operational intelligence.
Right. So if the old way of deploying an AI was like handing a new employee the keys to
To a massive filing cabinet.
handing them the keys to a massive filing cabinet and just wishing them luck. This new approach we're seeing with Microsoft Dataverse is fundamentally different. It's not just handing them a static company handbook either.
No, it's way more dynamic than that.
It's more like handing that agent a live, interactive map of the company's entire plumbing system. So if the agent turns a data valve over in the sales department, the Dataverse shows them exactly how that action increases pressure in the legal department's pipes.
That is a phenomenal way to conceptualize it, actually. Dataverse builds a relational graph. It's evolving into what Microsoft explicitly calls an agent data platform.
An agent data platform.
Yeah, it sits between your raw data and your AI, and it provides the schema, the semantic relationships, and the business logic. So if an agent tries to apply a discount, Dataverse informs it, hey, this specific customer tier requires manager approval first.
Which gives it that context it was missing.
Exactly. And this architecture is going to be everywhere. By 2028, Gartner predicts that over 33% of enterprise apps will have embedded AI capabilities.
Wait, a third of all applications?
A third, yeah.
That's wild. And looking at the Dynamics 365 and Power Platform updates, they're pushing this a step further with the Power Apps MCP server. Now, MCP stands for Model Context Protocol, right? But the critical feature here is that it introduces closed-loop learning for enterprise agents.
And this changes the entire life cycle of an AI model.
How does that usually work, the life cycle?
Well, usually, if an AI agent makes a mistake, say it routes an invoice to the wrong department, a human data science team has to analyze that failure, write new custom instructions, and manually retrain or update the model's parameters.
Which requires an army of engineers just to maintain the agent's baseline competence.
Exactly. It's exhausting. But with closed-loop learning on the Power Apps MCP server, the agents autonomously adapt from real-world feedback.
So they fix themselves?
Pretty much.
Yeah.
When they execute a workflow and encounter a business rule they didn't anticipate, or a user corrects their output, the agent updates its own operational context. It rewires its own understanding of the business logic without human intervention.
Okay, wait, I have to challenge that. Because autonomous learning sounds great until the agent learns a bad habit.
Oh, sure.
Like, if an agent is constantly corrected by a sales rep who routinely bypasses compliance checks just to close deals faster, what stops the agent from permanently learning that bypassing compliance is the new standard operating procedure.
And that is exactly why the agent data platform, that Dataverse layer we just talked about, is so critical.
Huh.
The closed-loop learning doesn't just happen in a vacuum.
It was constrained.
Highly constrained. It happens within the rigid, unalterable guardrails defined by the Dataverse schema. So the agent can optimize its workflow, sure, but it cannot rewrite the fundamental plumbing of the organization.
Oh, okay. That makes a lot of sense. The framework protects the business from the agent's own learning curve.
Exactly.
So moving over to the DevOps and SRE side-site reliability engineering, if you're an engineer tasked with building these guardrails and orchestrating these agents, the tool set is completely changing.
Rapidly.
Visual Studio has now integrated a debugger agent to actively hunt down code issues. And developers are shifting toward deploying with the Microsoft Agent Framework via Foundry-hosted agents. But the update that really caught my eye was regarding GitHub agentic workflows, specifically their effort to improve token efficiency.
Token efficiency is arguably the most critical metric in agentic architecture right now.
Because it's expensive.
Very. Every time a model processes a word, reads a file, or even just looks at a tool description, it consumes a token.
And tokens are literally the currency of compute here. But it's not just about the output, is it? I mean, the GitHub team realized that the system prompt, that the set of instructions and custom tools you give the agent before it even starts working, acts like a massive permanent tax.
A huge tax.
Yeah. Like if you load an agent up with highly specialized custom-built model context protocol tools, those tool descriptions just sit in the context window. It's like you're paying rent on that text for every single API call the agent makes, even if it never uses the tool.
Which becomes incredibly expensive, and it slows the model down. The breakthrough for the GitHub team was surprisingly simple, though. They just stripped away all those custom MCP tools.
Wait, really? They just got rid of them?
Yeah, and they just gave the agent access to the standard GitHub command line interface, the exact same CLI the human developers use.
That is brilliant. Instead of forcing the AI to carry around this heavy, custom-built toolbox, they just dropped it in front of the standard human terminal.
Exactly. It dramatically reduced the context window tax, making the workflow significantly faster and way cheaper to run.
And so that is the builder experience, but the everyday user experience is also transforming, isn't it?
It is. Microsoft 365 Copilot is being upgraded with the GPT-5.5 Instant model.
Which is largely about latency, right? Like getting the response time down in Word, Excel, and PowerPoint so it actually feels like a synchronous collaboration, rather than, submitting a query and just staring at a loading bar.
Exactly. But the real shift happens when end users start building their own specialized workflows.
Oh, there is a fantastic example in Andrew's notes about Mike Francis, a Microsoft Cloud Solution Architect. He was basically drowning in information overload, which I think is something every single IT professional relates to.
Oh, absolutely.
The Microsoft 365 Admin Center publishes this daily flood of updates, roadmap changes, and critical alerts.
And manually triaging that daily feed is an agonizing, time-consuming process. So he built a declarative message center agent to do it for him.
Right. And he didn't write complex back-end Python scripts to do this. He built a declarative agent that uses pagination and API calls.
Yep.
And just to clarify that mechanism for you listening, because an API won't just dump a massive database into your lap all at once. It restricts the data to maybe 50 results per page. His agent has the autonomy to loop through those pages.
It keeps its place in memory.
Yeah. It reads the admin updates, filters them based on his specific organizational needs, and then drafts a triage email detailing all the critical changes.
It is a perfect micro-example of the agentic shift. Like, it's not a chatbot summarizing a pasted article. It is an autonomous worker executing a multi-step data retrieval and communication workflow.
I do have to point out the sort of meta layer here, though.
Oh, the irony.
Yeah. We have literally reached a point where human engineers are building AI agents to autonomously read the daily update logs about the systems that run our AI agents.
It's very Inception.
It really is. But stepping back from that, if Mike Francis's agent is autonomously looping through admin logs and other agents are executing CLI commands and writing SQL queries across our networks, traditional firewalls are essentially useless now, aren't they?
Completely obsolete. You cannot secure a network where the internal entities are autonomously executing code by simply building a taller wall around the perimeter.
Right.
The only way to secure an AI-driven system is with AI.
Which brings us to security, compliance, and privacy, and Microsoft's announcement of the MDASH, the multi-model agentic scanning harness. The sheer scale of what this system does is staggering.
It's incredible. MDASH was built by Microsoft's autonomous code security team, and it represents a fundamental departure from how we previously used AI in security.
Because it's not just one model anymore.
Exactly. Instead of relying on one massive language model to spot suspicious code patterns, MDASH orchestrates an ensemble of over 100 specialized AI agents.
And they use an adversarial debate mechanism. From what I understand from the sources, it's essentially a massive automated red team versus blue team exercise.
That's exactly what it is.
You have attacker agents writing exploit code, defender agents trying to patch it, and judge models evaluating the success of the exploit.
Yep. And they aren't just theorizing about vulnerabilities. The agents actually have to compile and execute the exploit code end-to-end to prove the vulnerability is real.
Which is wild.
And to validate this architecture, Microsoft ran MDASH against the CyberGym benchmark, which is this industry-standard gauntlet of over 1,500 real-world vulnerabilities. MDASH scored an 88.45%.
Beating Anthropic's Claude Mythos model by a massive 5-point margin.
A huge leap.
And because the agents have to physically prove the exploit works by running the code, it virtually eliminates false positives, doesn't it?
Yes.
They pointed MDASH at Microsoft's own internal code bases ahead of Patch Tuesday, and it autonomously discovered 16 previously unknown vulnerabilities, including highly complex deep kernel flaws, and it flagged 0 false positives.
Which, for a security operations center, 0 false positives is the holy grail. It means human analysts aren't wasting hours chasing down phantom alerts.
But this raises a terrifying kind of existential question for the security industry. If Microsoft is using an ensemble of 100+ agents to successfully hunt down zero-day vulnerabilities for defense, what happens when highly resourced threat actors open source the exact same multi-agent architecture for offense?
And that is the grim reality of the AI cybersecurity arms race.
Yeah.
Because the architecture itself is agnostic.
Oh.
A multi-agent framework designed to discover and patch a vulnerability can absolutely be inverted to discover and exploit one before the patch is ever even written.
Which changes the timeline entirely.
Completely. This is precisely why defense at AI speed is no longer just an optional upgrade. If attackers are deploying autonomous swarms to probe your network, human reaction times are irrelevant.
You just cannot have a human analyst manually reading logs to counter 100 agents working in parallel. It's impossible. And that arms race extends entirely to identity management as well. Looking at the Microsoft Entra updates, we mentioned at the top of the show that they're tracking 600 million identity attacks daily and blocking 7,000 password attacks a second.
Passwords are dead.
Yeah, passwords are dead. But even modern solutions like passkeys have a fatal flaw, don't they?
They do, but the flaw isn't the passkey itself. It's the fallback mechanism.
The recovery process.
Right. If you lose the device holding your passkeys, the system has to give you a way back into your account. And historically, that fallback has been an SMS code, an email link, or a PI.
Which completely undermines the cryptography of the passkey. If a threat actor can just swap your SIM card or intercept an SMS, they basically bypass the high security lock entirely by just walking through the low security fallback door.
Which is why the Entra suite is deploying face check to replace those traditional passkey fallbacks.
Oh, interesting.
Yeah, for high assurance scenarios like remote onboarding or requesting elevated access privileges, the fallback mechanism is now tied cryptographically to your actual physical biometric identity. It severs that weak link in the recovery chain.
Wow. So we've covered an immense amount of ground today. We have autonomous agents managing satellite-connected edge devices, learning from their own mistakes in Dataverse, executing GitHub commands, and hunting down kernel exploits.
A lot.
It is a lot. And if machines are autonomously doing all of this, what exactly is left for us to do on Monday morning? Like, how do you stay relevant as a human engineer?
By elevating your abstraction layer. The machines are executing the workflows, but humans must architect the strategy, govern the guardrails, and understand the physical constraints of the systems.
And this is heavily reflected in the new learning and certifications tracks in the newsletter. The new beta exam, the GH600 GitHub certified agentic AI developer proves exactly that.
It's a clear signal that the baseline has moved.
Right. Prompt engineering was a parlor trick. Architecting multi-agent workflows is the new standard of engineering. But I was actually more fascinated by the update to the foundational AWS Certified Cloud Practitioner course for 2026.
Oh yeah, that one's interesting.
This is the entry-level cloud certification, yet it places a massive new emphasis on reviewing Amazon's sustainability reports.
Specifically, understanding Amazon's efforts to reduce water usage in their data centers.
Which sounds like an environmental science class, not a cloud engineering exam. But it's entirely connected to agentic AI.
It all comes down to thermodynamics. Running these massive 100-agent ensembles requires a staggering density of GPU compute power.
And heat.
Tons of heat. That compute generates an immense amount of heat, and cooling those servers at scale relies heavily on water evaporation systems.
So to be a competent cloud engineer today, you can't just know how to spin up a virtual machine. You actually have to understand the physical toll that your AI architecture takes on the local water table. The physical constraints of the planet are now a core competency of software design.
Exactly. Because knowledge is most valuable when you can see the secondary and tertiary effects of the systems you deploy.
Which leaves us with a somewhat philosophical question to mull over as we wrap up this deep dive. We talked earlier about enterprise AI moving toward closed-loop learning, right? Where agents autonomously correct their own operational mistakes within the Dataverse schema.
Right, the self-correcting agents.
But as we increasingly rely on these autonomous agents to manage our Kubernetes clusters, write our SQL queries, and secure our network perimeters, are we inadvertently putting human engineers in a closed loop of our own?
Oh, that's a dark thought.
I mean, if the AI is managing all the plumbing of the digital world, how long until we collectively forget how the pipes actually work?
It is a profound risk. Like if the AI intern gets promoted to chief operating officer and starts making all the micro decisions, the human CEO might eventually forget how the company actually manufactures its products.
Exactly. A creeping abstraction of human knowledge. It is definitely something to think about as you start your day.
For sure.
As always, the best way to guard against that is to keep exploring the underlying mechanisms yourself, dig into the sources, challenge the architecture, and understand the systems that are running the world. We'll catch you on the next deep dive.